Laplace transformation. To solve the linear differential equation, this is the third video. The first video shows how to solve the simple case using a D operand. Okay. The second video was about a specific solution for oscillation and wave. Okay, so that's the kind of most important solution of linear differential equation. Now here the third video show you how to solve the linear differential equation much easily using Laplace transformation. This was invented by mathematician Laplace, and transformation form is this. Any function is going to be transformed by this integral into fs. So ft become capital Fs by this transformation operation. What's so significant about this transformation is, for example, various functions all become kind of algebra format. You see this? Okay. So this is most important part. Second is like a shift function is simply shift. The transformation go back and forth. So if there is a s plus 3, for example, s plus a square minus b square over b, you compare with this formula, the difference is only s plus. So that's what it is here. Then the reverse transformation is going to be the EAT and FT. FT is sine HAT. So you have extra term here, okay? And the linear formula is anything you add and transform is going to be the addition of a transformation with coefficient preserved. Now scale function is when you scale time scale, then transformed function will be 1 over a and s over a. Now this is the most important one. Derivative function of transformation. You transform the derivative function, then it's going to be fs minus f0, and the initial value comes in. Okay, so using this, the idea is any linear differential equation you transform and get only those algebra format and solve that algebra and transform back to original, then you get the solution. That's the idea of Laplace transformation. Here's an example. Say you have this differential equation, right? You transform both sides and use this equation. Important thing is you have to know the f0, right? And f dash 0. Well, assuming these proper numbers, we can get this kind of function which can be simplified into this. So we can transform back to exponent, so we get the fx. Okay, so this is the whole idea of Laplace transformation. Now we have a more benefit of using Laplace transformation. What happens is, like step function in engineering, there are many cases that we have to analyze what happens if you suddenly apply voltage V and you have a circuit and you give using switch V. Okay, it's called a step function. Then what's happened? It's called a transient analysis. So this step function, it's 0 until t equals 0. After t equals 0 and t plus t is positive, ft is 1. So the step function like that. So suddenly t is 0, you turn on the switch. Then what's happened? Okay, so this ft can be 1 over s. So suppose you have a linear equation equals step function. The step function, you take a Laplace transformation, this simply becomes 1 over s. And you can solve this algebraically and transformation back to the original ft. Then you can tell what's happened after you apply voltage. Okay, now impulse function is like, it's all 0 until t equals 0, suddenly go infinite amount of the impulse, then becomes 0 again. And transformation, Laplace transformation of this is simply 1. So we can use the impulse to the system. If mechanical system, you have a hammer and suddenly hit, right? That's impulse. So what's happened to the system inside? And that analysis, we can use Laplace transformation, because impulse function Laplace transformation is simply 1. So we can solve the fs into the simple format and convert back to ft. Then we know the solution, what kind of function it's going to be. So those transient analysis, it's very useful because it's non-linear event. Okay, so that's all about Laplace transformation. I know you don't learn this unless you are science or engineering degree in the college, but it's good to know if you like to extend your knowledge about math. This is one of the math that help you to solve the differential equation. I hope you enjoy these videos, and please click subscription if you want to see other videos. Thank you.